All right, let's talk about something we all deal with, the gap between what we think should happen and what actually happens. Today, we're unpacking the tool that lets us measure that gap so you can tell if your expectations really do match reality.
You know how it is. You have a hunch, a theory, a gut feeling about how things are supposed to be. But then you look at the real world and the numbers are a little different. So how do you know if that difference is just a fluke, random noise? Or is it a sign that something has fundamentally changed? That's the big question we're going to tackle.
So, here's how we're going to break it down. First, we'll look at this whole reality versus expectation thing. Then, we'll dive into two real-world cases. After that, I'll introduce you to the special tool you need to solve them, called the chi-square. And finally, we'll talk about why this evidence really matters. Okay, let's get into it. The core of so much data analysis really is this constant tug-of-war between what we expect to see, based on our theories, and what the raw, messy data from the real world is actually telling us. I want you to think of yourself as a data detective, right? You start with a theory, that's your expectation. Then you go out into the world and you gather clues. Those are your observations, your data. The million-dollar question is, do the clues you found actually support your original theory, or have you stumbled upon a whole new mystery?
So let's make this concrete with our first case. Picture a classic business problem. A company rolls out a new product and they're dying to know, did it actually make a difference? This is what we call a goodness of fit test. Basically, does our new reality still fit with our old expectations?
Okay, so here's the backstory. Before anything happened, the market was totally stable. Everybody knew that Company A had 30% of the customers, Company B had the lion's share at 50%, and Company C was chugging along with 20%. This was the world as they knew it. This was their baseline.
Now, if you translate those percentages into actual people, it looks like this. If we were to ask 200 customers, we'd expect 60 of them to go for Company A, 100 for Company B, and 40 for Company C. This is our perfect world, on paper, where nothing has changed. This is the theory.
But then things changed. Company C launched that shiny new product. So the researchers went out and they surveyed another 200 people, and this is what they found. These are the actual observed numbers. And you can see they're a little different, but are they different enough to mean something? Let's put them right next to each other. On the left, the theory. On the right, the evidence. Company A dropped from 60 to 48. Ouch. Company B barely moved, just down by 2. But look at Company C, the one with the new product. They jumped from 40 to 54. So, is this just random luck? Or did that new product launch actually work, stealing customers from Company A? We need a way to measure the total difference here.
Now, let's switch gears and look at our second case. This one asks a totally different kind of question. It's not about how well one set of numbers fits a pattern. It's about whether two completely different things are connected to each other at all. This is called the test of independence.
And here's the mystery we're trying to solve, this time from a brewery. They wanted to know a simple thing. Does someone's gender have any connection to the kind of beer they prefer? Light, regular, or dark? Or are those two things totally separate, totally independent? A super common question in marketing. So, just like before, they went out and gathered clues. They surveyed 150 people, and they organized all that info into this table. Now, this is just a fancy way of showing all the combinations. How many men liked light beer, how many women liked dark beer, you get the idea. The evidence is all in here, but just by looking at it, it's kind of impossible to tell if there's a real pattern or not.
So now we're a bit stuck, right? For both the market share case and the beer preference case, we can see some differences with our own eyes, but we have no way of knowing if they're legit. We need a special tool, something that can take all these little differences and boil them down into one single number that tells us what's going on. And that tool, my friends, is the chi-square test. It looks like a fancy X, but it's the Greek letter chi. And its entire job, its whole purpose in life, is to calculate one single score that tells you the total size of the gap between what you expected and what you actually saw.
So here's the main idea, and it's pretty simple. A small chi-square number means your evidence is pretty darn close to your theory. Things are pretty much as you expected. But a large chi-square number? Whoa, that's a red flag. That means reality and your theory are far apart. Something real is probably going on. Okay, you're going to see this formula, and I know, it looks a little intense. But ignore the scary symbols for a second, because the idea behind it is so simple.
For every single category, you just do this. You find the difference between what you saw and what you expected, you square that difference, and then you divide by what you expected. That's it. You do that for all the pieces and then just add them all up.
Let's see it in action with our first case, the market share problem. You can see in this table, we're doing that little calculation for company A, then for company B, and for company C. Each one gives us a piece of the puzzle. Then we just sum up that last column and we get our one magic number. And that number is 7.34. This single value captures the total difference between the old market share theory and the new reality. Remember, the bigger this number, the bigger the gap. And we do the exact same thing for our beer case. We just apply that same simple logic to all 6 of our little boxes: male and light, female and light, male and regular, and so on. We run each one through that same process to find out how different it is from what we'd expect if there were no relationship.
And for the brewery case, the final chi-square value comes out to 6.12. So now we have our key pieces of evidence, a 7.34 for the market share case and a 6.12 for the beer case. So what do we do with these numbers? This is the moment we've been waiting for. This is the final act of our detective story. We've gathered the clues, we've used our special tool, and now it's time to deliver the verdict.
So here it is. Statisticians have figured out that if your chi-square number is bigger than a certain cutoff point, you can be pretty confident the difference you're seeing is real, not just random chance. And for case number 1, our 7.34 is well above that cutoff. The verdict? The difference is significant. That new product absolutely worked. And for case number 2, our 6.12 is also significant. The verdict? Gender and beer preference are not independent. There's a real connection there for that brewery to explore.
And that's really the beauty of it. The chi-square test lets us move past our gut feelings. It takes us from saying, that looks kind of different, to being able to say with confidence, yes, the pattern we're seeing here is statistically significant. It turns hunches into evidence. So I'll leave you with this thought. You now have the key to testing your own expectations against reality. It could be in your business, in a project, or even just something you're curious about in your own life. What hunches do you have that you'd want to put to the test?